Hello everyone. So we are back to the design series and today we are going to see the proxy design pattern. So proxy design pattern is first of all a structural design pattern which provides you a placeholder for another object to add some controls to interact with the client. So let us take an example and try to understand what majorly it does. Let us say you're connected to certain network in your offices. You're connected to some Wi-Fi. So they have some restrictions over website. Let us say you are not able to open the Gmail or the Drive links as well. So they have certain restrictions. So those restrictions are between the client and the actual code. And this is implemented through the proxy. The proxy, it adds an extra layer of control. So that extra layer can be helpful to provide certain functionality to have some logging or caching or access check and all of those functionality. So let us go ahead with an example for a car system and let us try to implement an example. So we have proxy.cpp hash include iostream using namespace std. So we are going to take an example of a vehicle system where the actual vehicle class is going to only have a function called drive. It does not check anything. It just gives you a car object and you can drive it. So let us create an interface first. So we can say subject interface. So let us name it vehicle only, vehicle. Now inside the public section, we'll be having a method called drive, virtual, void, drive. It will be pure virtual function. And we'll also be having a destructor vehicle default. Now after this we'll be having a real object which is actually in control, real subject, you can say real subject. So class car which publicly inherit vehicle, and inside the public section we have to override the drive method. So void drive override. I'll just see out car is being driven and endl. So this is the real class, but we want certain functionality to be checked, which is whether the driver has a license or not. If he has a valid license, only then he should be able to drive the car. So what we'll do is we'll create a proxy class, say car proxy, and it will also implement the same interface. So that is the important note here, that even the proxy class will implement the same interface. So public vehicle will be having a car instance inside the car proxy, a real car, and then we will be having a license that we want to check, string driver license. Now inside the public section, we are again going to override the drive method. But before that, we'll also be having a constructor. So car proxy string license. Now inside the license, I'll first assign the driver license with license. And after that, the real car object will be assigned with null pointer. because in the initial point, we don't want it to be created. When the user is going to drive the car, at that time we can assign it, right? We can save some memory at that point of time. So the next method I have to override is drive, override. Now inside the override, I'll first check whether the driver's license is valid, whether it is valid or not. Now, if my real car is null, or if it exists, then I don't have to create anything. But if it is not created yet, then I'll be creating one, and I'll say the real car is equal to new car, right? Once this is done, we can log out something. Let us say access granted and handle. Now the user can drive the car, so we can call the real car and we can start to drive. Okay, it's a function. Now, in case it is, say if it is not valid, else, okay, even if the user is not having a, if it is not null, then also he should be able to drive the car. So what I'll do is I'll just pick these two lines out and I'll move them out of the if condition. Miss that point. So inside the else, I can just see out that access denied because the license is over. I can just send it. And then we will be having a car proxy destructor, say car proxy destructor, which has to delete the new real car which we have created. So delete real car. So you should always be concerned about what all memories that you are allocating so that you have to free them. You have to manage the space as well. Now inside the int main, what the client will be doing is, first of all, we'll be creating a vehicle pointer, say car1, or let us say car, and new car proxy. Inside car proxy, I can pass valid if the license is valid, and I can straight away call car drive, and that will be allowed. In case I'll say vehicle pointer car2 is equal to new car proxy, and I'll pass invalid, and then car2 drive. When I'll call it, it will not be allowed to drive. So let us compile it and see if there are any errors. G++ proxy, let us name it pro. So it compiled successfully. Let us try to run it. And for the first vehicle, the access is granted and the car is being driven is printed. For the second one, access denied is there. So this is how you can add certain functionality using the proxy class where you want something to be added between the client and the actual code. You want some access control. So that's why it is sometimes called like it is having a placeholder. It acts as a placeholder for the real object. So that is all about the proxy design pattern.